Facebook dah tak jadi. Selama ni bila kami buat Facebook live dekat group tak ada masalah. First time got masalah. Why I'm not sharing it public? Because this lecture. Okay. Okay. So. Okay. So YouTube dah jalan. So afterwards I can share with you all the link. Alright. As usual, I'm going to spotlight myself. Okay. So very sorry about that. Okay, welcome to Dr. Rashidi. You do your PhD in UKM? Kena mute. Okay. Alright.
Semester 7.
Alright. Okay. Okay, thank you for coming to the class today. Today is very basic. Since I already have the 13 attendance, I'm going to shut down the attendance. So I'm going to start with the class proper. So for the class proper, as usual, you're going to go to drtamil.me. Okay, so here for the class, under drtamil.me, when you click on FK6193, you have all the lectures there. Yeah. So the nice thing about our lectures, everything is done like this lah. So it's very easy. Alright, so okay. So I'm clicking on multiple linear regression. So as you can see, there are three sets of things. One is the lecture itself. Then we have the SPSS file for the exercise, and we have the video. Okay, so this one is a video from the past. Okay, so it's not going to be a problem. So I'm just going to download this one. Okay, next. I'm going to download the screen hilang lah. Okay. Okay, so view, post remote. I got my cat coming through the window. Okay, next I'm going to show, I'm going to try to get the PowerPoint to be presented at the right place. Right now it's at the wrong place. Okay, so this is the PowerPoint. Okay, view, post remote. So you should be able to see this right now. The other one is I'm going to download the data set. So the data set for the exercise today is from that website. Okay, so let's hope I can open up that screen. Okay, so this is the SPSS file. Just click download, and it will download the file to your desktop. Okay, so we're going to run the exercises as we go along with the lecture and explain the lecture accordingly. So again, I repeat back, this is the most basic of all the lectures, which is multiple linear regression. You have had this lecture before. Okay, if you're from my class, you already had this lecture before. So basically, this is just a revision. So I'm not too worried about that. Okay, so we already have that thing done. Okay, so I'm going to close down this window. Okay, we have the lectures being projected. Okay, now my SPSS is opening up. Okay. All right. So this lecture slides are originally from Dr. Ayub. Okay. So uh, he gave me permission to use these slides to teach you all in class. Okay. But I did not get his permission to teach on Facebook. So that's why I did not share his slide publicly on Facebook. Okay. So we're just going to use it only for this class. Okay. And the link I'm going to tarik from YouTube and send it to you all on the Facebook as usual. Okay. All right. So that is the story about the slides and the PowerPoint and the data set. So let's start the class. Okay, so we're going to talk about multiple linear regression. Okay. So as a revision, we're going to cover simple linear regression first. Then we're going to talk about the basic theory of multiple linear regression. Then we're going to go through the steps by steps of doing multiple linear regression. Then we're going to talk about how we handle the analysis. Oops, my computer is running out of battery. Okay, the plug is taken a bit loose. All right. Yeah. Okay, so let's start the class. Okay, I just set it here. Okay, right now I'm trying to arrange everything so that you will be able to see that whatever that was discussed. Because right now everything is on the wrong screen. Okay. Okay, so now we should be okay. 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 So again, I repeat, this is a basic lecture. It's a very basic lecture. So for those who are very well versed already, you are okay. There's no need for you to continue. But for those who want to just enjoy the lecture, okay, you can just listen in. Okay, so we talk about regression. So basically, when we collect data, and if the data is continuous in nature, for example, we measure age, continuous in nature. Then we have the cholesterol level. It is also continuous in nature. So age, we have the age in years, 1, 2, 3 till 100. Cholesterol, we have the cholesterol level. So it could be from 1 until 10, 11, 12. Okay. So if we're trying to determine the relationship between age and cholesterol level, you can use either correlation, Pearson correlation, or regression analysis. Why? Because both are continuous data. Both are continuous data. So what's the difference between correlation and regression? If you're doing Pearson correlation, as stated before, it shows the strength of relationship. It shows the strength and direction of the relationship. So is the relationship positive or negative? Or is it weak, fair, moderate, and strong relationship? Okay. But if you're doing regression, you can predict the outcome based on the risk factors. You can predict the outcome based on the risk factors. In this scenario, cholesterol is the outcome. Age is the risk factor. Why? Because age can determine the cholesterol, but cholesterol cannot determine the age. So for example, when we do the scatter diagram, it looks like this. Okay, we have the age in years, 20 to 60 here. Sorry. Then we have the cholesterol level. Okay, the highest is 10. The lowest is 6. Okay, and we can see that there is a positive. Y positive is going up and to the right, and it is a positive relationship. Okay, between age in year and cholesterol. So what does it mean with positive relationship? As I grow older, my cholesterol level will go up. Okay. Okay, my cat is going out from the window again. I guess he did not find the food downstairs. Okay. Okay. So how we do simple linear regression? It is simple. Okay, it is simple. So I'm just going to show quickly how we first explore the data. So we first explore the data by using scatter diagram. Okay. Right now I'm going to go to my SPSS. As you can see, my SPSS is version 26. This is the evaluation version. This is the evaluation version. Okay. For subscription. All right. So we're going to run the analysis. So I'm going to get the graph, legacy dialog. I'm going to select scatter. Okay, what is the risk factor? It is the age. Okay, so risk factor is the age. So age in year is on the x-axis, and the outcome is the cholesterol level, which is the y-axis. So when I click there, I click OK. I will get the diagram. Okay, and the diagram looks like this. Okay, for you to get the whole thing to come out in the way that you like, so you have to customize the chart. So customize the chart, you double click, you get the chart editor. Okay, being OCD, I tend to focus on this first. I will focus on the minimum maximum value. So I will go from 0 until 55, apply. Then I will go to the minimum from 0 until the lower margin. Okay, so you get something like that. Okay, so this one, so you can see the line looks like that. So right click, add fit line at total. Okay, immediately you get the chart. If you want to customize the chart some more, you can just double click on it. The chart size, you can increase up to 800. The height up to 800. Okay, apply. So you get a nice big chart there. Okay, so now we're done. You just cancel. Then you get a nice big chart there. Of course, it may not fit, so maybe you want to change. Go back chart editor, right click, properties. Okay, I'm going to reduce it to 600. Okay, apply. It's much better. All right. Okay, so this is a chart, scatter diagram. Okay, so you can see the A constant is around here, 5.9, I think. Okay, the R square is 0.109. Okay, so this is scatter diagram. So why we do this? We want to show through exploration of the data by doing a scatter diagram that the relationship is positive and there is a linear relationship between age and cholesterol level. Okay, so that's the basic about simple linear regression. How we do the analysis, very simple also. Okay, as you can see inside this analysis, when you analyze, if you can just click analyze, regression, linear, just move the age in here into become independent, cholesterol level as dependent, then just click OK. So when you click OK, you get the results immediately. So as mentioned now, the constant is around 5.9 and the steepness of the slope is 0.058. The steepness of the slope is 0.058. So this one, the steepness of the slope is 0.058. Okay. So that is simple in regression. Okay. So we already shown you how it is done. Okay. To get the confidence interval, you have to click the button for confidence interval. So you just click here. When you run the regression, okay, option 95%. Continue. Statistics. Okay, 95% CI. Click OK. Continue. Click OK. Then your chart, your results will include the 95% CI. Okay, as you can see, it does not cross the value of 0 here. So since the CI does not cross the value of 0 here, so the regression coefficient is significant. The regression coefficient is significant, and the regression coefficient is 0.058. Okay, so that is how we do simple linear regression. Okay, so you can see here, these are the discussion. Okay, this is the plot that I showed you earlier. Okay, so as you increase in age by 10 years, the cholesterol level increased by 0.6 millimole per liter. Okay, so how they come up with the line? Okay, they come up with the line by trying to draw the line that will generate the least square differences between the observed value and the expected value. So they have this line, and this line generates the expected value. So compared to the observed data, whatever data they observe, you get the differences, and you want the differences to be as small as possible. So the line is the line that generates the least square differences. Okay. If you look up the notes under structural equation modeling or anything like that, they will call this as LSO. LSO. I had to look it up. What does it mean? So the LS stands for least square. Okay. Oh, I forgot already. So basic theory of MLR. Basically, everything that we have here is not determined by only one factor. For example, cholesterol level. So your cholesterol level is determined by many factors. Among them are diet, exercise, socioeconomic status, and age. Okay. So if using this example, diet, exercise, socioeconomic status, and age. And as you all know, when you do simple linear regression, age, diet, exercise, and socioeconomic status with cholesterol, it will be significant. But I think we all realize that between age and diet, age and exercise, age and socioeconomic status, they are all correlated. They are all correlated. And there could be interaction between all these things. And whatever effect that you have from age is inflated by the effect from the others. So we have to adjust. If we run the relationship together at the same time, we will get the real independent effect of age, diet, exercise, and socioeconomic status towards cholesterol. Okay. So the whole point, as mentioned just now, when we do everything together as multiple linear regression, you will get in the independent effect of each one of these explanatory variable. So you run multiple linear regression, you get the independent effect for age, for diet, for exercise, for socioeconomic status. Okay. And at the same time, you can also study the interaction, okay, between the independent variables. Whether the interaction are synergistic or antagonistic. Okay. For example, okay, we are talking about the effect of age and cholesterol. Okay. But we have to take note also, old people exercise less. Old people exercise less. So there is some interaction here between age and exercise. Older people have less exercise. And those who less exercise, they end up with high cholesterol. Those with older age group tend to have higher cholesterol. So there is some confounding effect between each other, or some interaction or anything like that, between this and the outcome of interest. So the effect that we found here is not only the pure effect of age, but also the additional effect from exercise. Older people have less exercise, so that the relationship of being high cholesterol among older age is exaggerated by the effect of less exercise. Okay, so the result, if the interest is between cholesterol and age, it is confounded for by exercise. Okay, it's confounded for by exercise. And here, if your interest is between cholesterol and exercise, now it is confounded by age. Now it is confounded by age. So it goes both ways. But if you run them together inside the analysis, age will control for exercise, exercise will control for age, then you get the independent effect of each variable for age and exercise. Okay, so all these interaction, there are positive called synergistic, and there are negative called antagonistic. Okay, so for the positive we call synergistic, for the negative called antagonistic. So for example, if you you're trying to say diet and exercise has equal effect on the cholesterol. So the diet effect, for every increase of 1 unit of diet will increase 1 millimole per liter of cholesterol. For every reduction of exercise by 1 hour, will increase the cholesterol level by 1 millimole per liter. So what happened now? When you run the analysis, we are looking for whether there's any interaction. If you're 1 plus 1, you end up with 2, then it is a combined effect. No interaction. But if with the 1 plus 1, you end up with higher, for example, 2.5, then it is a synergistic effect. For 1 plus 1, then you end up less than that, so you only get 1.5. So there is the combined effect is antagonistic. So antagonistic interaction. Okay, so that is the explanation about synergistic and antagonistic. So it goes up too high, it is synergistic. If it is does not go up as much, much less in fact, then it is antagonistic. Okay. So that is the story about the theory of multiple linear regression. So I'm going to explain about this analysis. Okay. So we have the analysis of multiple linear regression. We also use it to explore whether there's any association or influencing or risk factors to the outcome. This one we just try to explore. Okay. Then we have to confirm or you're trying to come up with a prediction model, okay, or trying to confirm a specific relationship. Okay. The theory, we already discussed this at length during the first week. Okay. So here the cholesterol, you have the dependent outcome. Okay, the dependent variable of the outcome. It must be numerical. That's a keyword. It must be numerical. Okay, then you have the risk factors. Then you have the risk factors. Which is the age, diet, exercise, and socioeconomic status. If they are all continuous, okay, and these are our independent variables, if they are all continuous or numerical data, then we call this multiple linear regression. When I started learning about this way back in 1996 and 7, okay, memang I only learned the only thing I can do from MLR, everything must be continuous data. But only later on, we started to integrate categorical data. So why categorical data? Because when we run analysis for GLM, general linear model. So when we run analysis for GLM, general linear model, there's a mix of continuous data and categorical data. So now, since MLR is also a form of one of the subset of GLM, so they decided that you can include the categorical data inside this analysis, but to avoid misunderstanding, they don't call this one as MLR, they call it as GLR, or general linear regression. Okay, so if you have categorical data inside the risk factor, not only the continuous data, so we call it GLR, general linear regression. Okay, I think this one you're familiar already. We have covered this again and again. So y equals to beta 0 plus beta 1 x1 plus beta 2 x2 and so forth. The beta 0 is really the constant or the error. Anything that cannot be explained by this formula will be dumped into the constant, and that is your beta 0. Okay. Okay. So now we are going to go through the exercise. For those who got 2 computers and want to do it alongside of me, can do so. Okay. But for those who have only 1 computer, maybe you will watch this video later to do the exercise together with the SPSS data. Okay. So first we're going to do data exploration. Okay. Then we're going to look at the scatter plots for each one of them. Then we're going to run the preliminary main effect model, then preliminary final model, then the final model, the interpretation and data presentation. Whenever there's any problem, you have to do remedial action. Okay. Okay. So let's do the data exploration first. So first and foremost, you have to understand these data are what. Okay. So usually for me, I always start with frequency. So select everything inside there. Transfer to the right side. Okay, just run frequency. Okay, what do you get also, because these are all continuous data, you should also get the mean and standard deviation, minimum and maximum. Okay, so you can see here the cholesterol level, the minimum level is 6.1, maximum level is 10. Okay, the mean is 8. For the diet, okay, diet, this one you have to be very careful. This one is not really continuous data. They are really ordinal data. Okay, they are really ordinal. Why? Because we have categorical data 1 till 7. Okay, based on the classification. Duration of exercise, hours in a week. Okay, this one is continuous data. But if you look here, the minimum is 2 hours per week. The maximum is 6 hours per week. Okay. For economic state, socio-economic status, again, this one is ordinal data. Okay, the minimum value is 3, the highest value is 19. But because this one is quite large, more than 15 categories, okay, if you run it, the computer will treat it as though it is continuous data. Even if you're doing if you're doing SEM, so on and so forth. Okay. So looking at that, you look at the frequency, okay, for each one of the results, so you can see already what sort of frequency you are having in terms of diet, duration of exercise, socioeconomic status, age in years, so on and so forth. Okay. Next, you explore to check for normality. Click Analyze, Descriptive, Explore. Again, the same thing. Okay. This one just standard thing. We already covered this during the basic statistics. So you all should be very well versed already on what button to click. Okay, once done, click on OK. Okay, now we have the results. Okay, so when you explore, one of the syarat, one of the requirement, all the data should be continuous in nature and they are normally distributed. So how do you know they're normal or not? Okay, the mean, the mode, the median should be the same. So 8.1, 8.3, 4.78, 5. This one is 4.26, 4. Problem too. So social media 11.05, 11, 39.54, 39. Okay. So they are okay lah. This seems to be okay. Okay. Looking at the rest, skewness ketosis okay for cholesterol. Skewness ketosis okay for diet inventory. Skewness ketosis okay for duration of exercise. Skewness ketosis okay for socioeconomic status. Age in years okay for skewness and ketosis. So it looks to be like normal. If you look at the KS test, the KS test says that your data is not normal for diet and duration of exercise. looking at the data set, okay, our data set is 82. Our data set is 82. So by right, we should follow this KS style. So it does show that our data is not normally distributed. We know why, because basically they are not really continuous data. They are really categorical data, or sorry, ordinal data. Okay. So in fact, there is a problem here. If you want to argue, this one cannot be included because it is not really continuous data. The rest are all okay. Okay, it shows that your histogram, your KQ and Q plot is all okay. The histogram, so forth for the rest. Okay, the two problem was exercise. So you can see that those who exercise more than 6 hours are much less. That's why there's a problem there. Those who exercise very little, less than 2 hours, also very much less. All right. So that's why it is not normal. All right. Okay. So that is the how we explore. However, in this case, we just decided to close one eye, tutup sebelah mata, so that we want to run this analysis for multiple linear regression. Based on the explorations now, we already shown two of the data set, which is the exercise and the diet score is not really normal. Okay. Sorry, slept late last night. Bangun sahur, then you know lah. After that, you'll be sleepy. Should have slept earlier. Okay, so now we have shown that. Okay, we're going to proceed with simple linear regression. Any questions up till now? Should be okay, kan? You have done this many times. To the extent that I get bored teaching this already. Okay. Okay, let's look at the simple linear regression. So we have to do simple linear regression for all the variables. We have to do simple linear regression for all the variables. We have to do the scatter plot also for each of the variable. Then you are supposed to discuss. Okay. So to do that is very easy. We have shown it just now. So I'm just going to do. Yeah, hello.
Assalamualaikum.
Waalaikumsalam. Yeah, Ahmad.
Can I ask a question, Prof?
Can.
For our data and our thesis, to decide on normality, on which one of them, if there is a problem, Kolmogorov or kurtosis or median mean?
Okay. To answer that, I will go back. Okay. I know because you came in just for the advanced class. You didn't come for the basic class. So I'm going to open up the slides for the basic class. This one, the others have covered this, so don't worry. So I'm just going to show it for those who are from the PhD group who are not familiar with this.
Okay. Barakallah. Thank you.
Okay. I need to share the screen again. Okay, the question is about how to decide whether your data is normal or not. Okay, we had covered this under FK6193. Okay, so it is under data exploration. There's a topic of lecture called exploratory data analysis, EDA. This one, CL4. Okay, so I'm just going to proceed direct to the slide of concern. which one to use? Are you going to use skewness kurtosis? Are you going to use KS test? Okay. It depends on your sample size. If your sample size is less than 30, always assume it is not normally distributed. If your sample size is less than 30, it is not normal. Doctor, I did the KS test. The KS test says my sample is normal, although it is less than 30. The reason why KS test show that you're normal, because KS test is only suitable for samples in 30 to 100. So anything less than 30, it is not normal. Okay. Even though your KS test says it is normal. For moderate sample size, 30 to 100, you can rely on the KS test. So if the KS test say that your data is not normal, yes, it is not normal. Okay. So 30 to 100, you can rely on the KS test. Is there any other normality test? There are 3 normality tests. The other one is Shapiro-Wilks, but Shapiro-Wilks only come up when your sample is above 100. And there's another one, I forgot the name, Davidson something. Okay, but all these other normality tests is not available inside SPSS. You have to use other software for that. For all the 3 normality tests, they are available inside GraphPad Prism. If you want to learn how to use GraphPad Prism, you can check out my notes on SlideShare. It is available there on how to use GraphPad Prism. If your sample is larger than 100, don't bother with the KS test. Don't bother with the KS test. If sample is larger than 100, you just look at the graph and the skewness and kurtosis. Okay. So you can check out the slides. These slides is at under Explore Summarize. Okay. Everything is here. Everything is here on the explanation whether how to explore it is graphical and statistical. Everything is covered here in detail. Okay. So just check it out. Just check it out.
Thank you, Prof.
Okay. Thank you. Okay. All right. So we have already proven our data are not really suitable for multiple integration. Which one are not suitable? One is the exercise data. The other one is the diet score. As mentioned just now, diet score is really ordinal data. Okay, but we're just going to assume that they are normal so that we can proceed with this exercise. Okay. To run this analysis, I'm going to show it very fast. Okay, because they are all the same. They are all the same. So click data, regression, analyze regression linear. Okay. So I'm just going to take out the age India, put in diet, click OK. Okay, so you got analysis for this. Then you click analyze. Okay, what is important? They are all significant. The beta value are all significant here. Again, click analyze, regression, linear, take out the diet, put in duration of exercise, click OK. Okay, again, they are both significant. Okay, the duration of exercise is significant. Again, click analyze, regression, linear. So we take out the duration of exercise, put in socioeconomic status, click OK. Okay, again, it is significant. So socioeconomic status also are a significant predictor for cholesterol level. Click analyze, regression, linear. Take out HU done already. Okay, that's it. We have done already. Okay, let's start the next one for the graph, legacy dialog, scatter dot, simple scatter define. Okay, as you can see, now we did for each India. We're going to take out the each India. We're going to put in the diet. Click OK. So you can see, this is what I say. It is really ordinal data. The diet is really ordinal data. It's really ordinal. Betul ordinal. And graph, legacy dialog, scatter, simple scatter define. Take out diet. Put in duration of size. Click OK. Same again. Nampak? You can see here. There's only 1, 2, 3, 4, 5 categories. So it is more like ordinal rather than continuous. If you want to ask me on how do you define ordinal and interval for the purpose of structural equation modeling, they will define it as those with more than 15 categories, and you can quantify the difference between each level. And the difference between each level is equal, sama. They have equal interval. So that is continuous. Here, we know, although it looks like equal, but we're not really sure. Yeah, because it depends on the person answering, whether they really have a special device to monitor how many hours per week they have already exercised. All right. Okay, next. Graph, legacy dialog, scatter, simple scatter, define. Take out duration, put in socioeconomic status, click OK. Okay, remember you got 19 categories. Okay, 19 categories. Okay, so it looks nice, similar like interval data or continuous data. So that is one ordinal data that looks like continuous. Regression, linear, take out socioeconomic status, or HCD already covered. Okay, so no need to do. So you got all this graph. Okay. So once we have done all this, we can come up with a table. You can come up with a table, you can come up with a graph showing all that. Showing all that. So this is a table. This is a table for simple linear regression. Okay, factors associated with blood cholesterol level among the study population, N is 82, using simple linear regression. So remember, this is SLR. So the beta that you get, or the regression coefficient you get, are the crude regression coefficient. It is not adjusted. It is not adjusted. Okay. All right. So you can see this is the CI, and this is the p-value. By the way, I got a new chair. There's no more red color there. This is designed for big fat person like me. Sangat.
Ya, tu yang ngantuk tu.
Betul lah. I really feel like sleeping right now. I think so. The reason is, although the original chair was stated for 35 kilogram, the one I'm sitting on is up to 155 kilogram. So it is much more. The older chair was giving out under my weight, so I had to get a new one. I got a good excuse. Wife chair is not comfortable, so I gave her my old chair. I got the new chair lah. Okay, but the problem is I'm going to lose this green room to my mother-in-law next week. So I'm still trying to figure out where to teach next week. Mother-in-law coming back. This is in fact my mother-in-law's room.
Oh, rupanya. Okay.
Aduh. Okay, so this is how you prepare the table for simple linear regression. All right. So that is simple integration. So now we're going to proceed with multiple integration. So we already done the first two parts, step 1, step 2. So now we are going to do step 3. Okay. Oops. Okay. Step 3 is very easy. Step 3 is very easy. We're going to do forward, backward, stepwise. Okay. Serentak. Serentak. Okay. And all 3 methods should be used. And the best model should be used for further analysis. I know the next question going to come up from you all is how do you define the best model? The best model is the one that includes the most variable and generate the largest coefficient of determination, and yet at the same time they are all significant. And yet they are all significant. Okay, so let's go and do the exercise. Okay, it's very simple. Just it is so easy to the extent that I feel no point teaching you all this one. Okay, regression linear. Okay, so I'm going to reset this one. Take out the left side. Select diet. Duration and size, socioeconomic status is in here. So you got 4 of the independent variables there. Shift to the right. Okay. Remember, these are all continuous data. Next, we click on this one. So you got forward, backward, and stepwise. Forward, backward, and stepwise. So we're going to start with forward first. Okay. This one, I'm not going to click yet. Why I'm not going to click yet? Because we're going to cover this by the topic. Real life, I'm just going to click all the necessary buttons at one go. But this one is exercise. We have to explain theory one by one. So we're going to go step by step. So the first one we do stepwise. That's why forward. Forward, they add on one by one. Forward, they add on the variable one by one. So you can see here, we started with the one with the largest regression coefficient. Okay, so the one with the largest, not the largest regression coefficient, this is the largest coefficient of determination. Okay? So the largest coefficient of determination was socioeconomic status. So they put that one first. Okay, so you can see here, p-value less than 0.01. Then they add on the duration of exercise. Both are significant. Then they add on the diet. But when they add on the diet and socioeconomic status are in fact highly correlated with one another. Okay. For example, you all are all very rich people. Buka puasa, breakfast, you eat biryani rice with lamb. The poor people, they eat plain rice with egg. So that's why the socioeconomic status and the diet score are highly correlated with one another. So in fact, when they are highly correlated with one another, they are explaining the same thing. So although this one for the socioeconomic status was significant earlier, the minute the diet inventory score goes in, they nullify the effect of the socioeconomic status. Because in fact, socioeconomic status and the inventory are one and the same. They are measuring the same thing. Okay. So in fact, the mediating factor here is the food that is being eaten. So this one, the socioeconomic status is the indirect effect. Okay. So it is the indirect effect through the mediating factor of diet, then the effect on the cholesterol. So that's why when this one becomes significant, this one becomes not significant. So you add on the last one, which is H in here. You got the largest value, the largest amount of variable, all 4. But the problem now, okay, although the R square, although the R square is the highest, 0.674, okay, 67% can be explained by this model. The problem now, one of that is not significant. So not a good model. So you proceed with the rest. again you click on regression. Okay, tadi forward. Now we're going to do backward. Okay, so when you do with the backward, same thing, but now you start from everything. You start from all the 4 variables. Then they remove the one that is not significant. The one that is not significant is again socioeconomic status. So now we come up with the best model. The best model got 3 variables. What is the R square? The R square is 0.678. Wow, much better. Much better than 0.674. So this is a much better model. The R square is better. Okay, so we can proceed with the next one. Stepwise. Analyze, regression, linear. So we take out this one. Go to stepwise. Click OK. Stepwise is like dancing. It's like dancing. You can go forward, you can go back. So you start with go forward first. Socioeconomic status, duration exercise, diet inventory. You put in diet inventory, 1 not significant. Then you kick out yang tak significant. So you kick out the not significant one. So you got only 3 left. Then you add on age. Okay, sorry. When you kick out from 3 become 2. From 2 then you add on age, then become 3 again. Okay, so again this one same like the backward one. So our R square is quite nice, 0.678. Okay, so this one comes out with the best possible model. So you can see now, when you run the exercise, you end up with, we did all 3, forward, backward, and stepwise. Okay, then, okay, these are all the buttons to click. We already covered, did that. Okay, and we come up with the formula. So based on the model that we had, the stepwise and the backward, the constant is 7.297 minus 0.540 exercise plus 0.394 diet plus 0.033 for each. And this is the same for with backward. So based on the 3 automatic procedures that we did just now, we agree on 1 preliminary mean effect model. So the preliminary mean effect model is cholesterol equals to 7.297 minus 0.54 exercise plus 0.394 diet plus 0.033 age. Okay? Okay. So now we are going to check for interaction. Now we're going to check for interaction. We got 3 models that are significant. We have got 3 models that are significant. So we're going to proceed with that 3 that is significant. And to check for interaction, if you remember back from the last time we had the class, it is a simple matter of multiplying each one of them. It is a simple matter of multiplying each one of them. So we check, we multiply exercise and diet, exercise and age, diet and age. Okay, I have the students exam at 10:30. That's why my handphone is so loud. Today I'm double booked, exam and lecture. Yesterday luckily I was quite free because suddenly I had to go to HUKM. So after the CPC was done, I was streaming it to YouTube. I immediately went to the HUKM because I got to settle a dry run for another hybrid event. So right now, whenever they have a hybrid event, I have to go and help. And that is not my kerja hakiki. Sorry. I'm supposed to press alternate tab. but I press something else. Okay, alternate tab. So I'm now going to look at the data set. Okay, I'm going to get rid of all these age group. I'm not going to use. Okay. So data analyze. So we're going to create a transform. Okay. Remember, the three variables that are significant is diet and exercise, then age. So first we're going to do target variable. We're going to put diet. Okay. I know we cannot use special symbol. I do not know why Ayub used this symbol star. Maybe you could just remind that it is. All right. So next, we diet times exercise. So diet times exercise. Click OK. Okay, so you cannot. So I know you cannot. Right, plus pun tak boleh. So diet exercise. All right. So you got one. Okay. So that is diet exercise.
Can use underscore, Prof.
Oh, underscore. Okay, thank you. Okay, let's see. Double click. Underscore. Okay, thank you. Thank you, Abdullah. So let's go to the next one. We're going to go and transform compute variable. So you got diet size, now diet age. Okay, this one we're going to take out exercise. We put in the age. Click OK. So we generated another new variable, age. Again, there's extra decimal point there, which is not necessary. Okay. So now, right now, you're seeing how obsessive compulsive I am. Okay. So transform compute variable. Okay. Then the last one is exercise and age. So I'm going to take out this one, diet, and change that with exercise. Click OK. Okay. So now you got all three. Okay. So you got, because you have three variables that are significant, so you have three pairs of possible interaction. Okay. Okay. So let's do the analysis for the interaction. Okay. So we already did this exercise. How to generate all the variables. Okay. So now we're going to check for interaction. Okay. How to check for interaction? We have to use the command enter. We have to use the command enter. So click analyze, regression linear. So we only put in those that we want to analyze. Those we don't want to analyze, we take out. So what we don't want to analyze? Socioeconomic status, take out. So we replace that with the first one, diet and exercise. Click. Okay, this one change to become enter. Okay. This one is compatible, correct. The rest, never mind, later. Okay, click OK. Okay, so this is the model. So you can see here, diet and exercise, not significant. The interaction term for diet exercise is not significant. Okay, let's do for the rest. Click Analyze, Regression, Linear. I'm going to take out the interaction term here, diet exercise, change that with diet and age. Click OK. Okay. Again, not significant. Again, it is not significant. Next, let's go back. Click Analyze, Regression, Linear. Put in the last interaction item. Click OK. Okay, again, it is not significant. It is not significant. So what does it mean? It means that there is no interaction between the three significant variables. And since there is no interaction, you can proceed with the analysis without the interaction terms. Only the three main variables, which is diet, exercise, and age. So you click on Analyze, Regression, Linear, take out all these terms, and now you can proceed with the next step. Okay, what's the
Sorry,
question?
Kacau. Sophia.
Yes.
While Prof is checking for interaction, the other variable in dalam X, yang independent variable tu, you tak payah keluarkan ke? It doesn't mean anything pun.
Right now, we are no longer including them in the analysis because we already proven that they are not contributing towards the final model. So socioeconomic status, we already proven that they are not contributing towards the final model, we take out.
Okay. Oh, so bila check for interaction, yang dalam tu mesti ada diet, duration mesti ada lah setiap satu tu Okay, alright.
So you can just pair it up. You can just pair it up.
Okay, thank you, Prof.
Okay.
Ya, kalau sekali harum tiga-tiga tak boleh?
Tak boleh. Tak boleh.
Okay.
If you look just now, whenever we run the analysis, one variable become not significant. For example, okay. You go back. Okay, you look here. Not only the interaction term is not significant, exercise also become not significant. Okay. So that's why when you're testing, you have to test it one by one. You cannot put in all three. Otherwise, they end up nullifying each other. So here, not only the diet is not significant, age also not significant, diet also not significant. Both end up being nullified. Here, diet and exercise, okay, it end up nullifying the diet inventory score. Okay, that's why we cannot do all three. We have to do one by one. Because remember, the term, remember last time we had the lecture on honest correlation. We have inflated correlation. When you have inflated correlation, when one of the variables is part of the other variables here. So they will nullify each other. Okay. So because of the inflated correlation. Okay. Kau dah lupa lah tu first week lecture. Aduh. I know. I remember because I have to teach it. After 20 years, that thing has been burned into my memory. 20 years already. All right. Okay. So, but the 20 years has been different lah. Whatever we teach has been different. Okay. So the first part was the interaction. Next is when we want to check for multicollinearity. So multicollinearity, okay, basically you're just looking at the error. Okay. Remember, we have the lecture on the inflated correlation. Okay. If they are highly correlated one another, then you end up with very high error values, and we end up with very high error values. The CI is very wide, very large. Then then maybe some of the variables that should have not been rejected end up being rejected. Okay, so you have to check for the problem of multicollinearity. Okay, so how to check? It is automatic. The term is collinearity diagnostics. It is automatic. Okay, so you just click analyze, regression, linear. Okay, we already had the 3 variables. Click on options. Okay, correct. Statistics. Click on collinearity diagnostics. Collinearity diagnostics. Click OK. I know I'm real life we click everything in one go. But here we are trying to explain step by step. So we're going through one by one. Okay? All right. So we did the collinearity diagnostic. You can see here. Okay. We have a model 1, 2, 3, and 4. We have the model 1, 2, 3, and 4. So but this one is enter. So by right it's supposed to be only one. Okay. So we look at the quality diagnostics. We have the dimensions 1, 2, 3, and 4. We have the eigenvalue. Only one. Only the first one is larger than 1. The rest are less than 1. Okay. Okay. So let's look at the PowerPoint. Okay. So after you click that, you end up with, by right there should be a VIF, VIF tolerance. So let's see whether they give you the VIF is now. Okay, got. So we have the VIF. So this is the VIF. Okay, there are 2 school of thought. Okay, there are 2 school of thought. Under Ayub school of thought, you look at the VIF. The VIF should be less than 6. The VIF should be less than. Sorry, VIF should be less than 10. The VIF should be less than 10. So the VIF is less than 10, then you are okay. You do not have issues of multicollinearity. Okay. But tolerance is the same like VIF, but tolerance is the inverse value of this. Tolerance is the inverse value of this. So what is the cutoff point? This one is the Y.H. Chan school of thought. For the Y.H. Chan school of thought, you have to go to the Y.H. Chan notes. Okay. Aha. Spooky. I'm looking back at the same slide. Okay. Yeah. I'm going to have to open up. Okay. Y.H. Chan, where to look for the Y.H. Chan? You go to drtamil.me. Okay. You click on references. Click on basic stats for doctors. Password Y.H. Chan. Okay, you have this. Look for multiple linear regression. So we have this one. Linear regression analysis. Okay, let's zoom in. VIF we have. Okay. So again, same thing about discussion about multicollinearity. Okay. But here the difference is here, tolerance. Okay, look here. Okay. So what you want it to be above 0.6. You want it to be above 0.6. Okay. So I show you back the table. So for the tolerance, you want it to be larger than 0.6. For the VIF, you want it to be smaller than 10. Okay. Then you don't have a problem with multicollinearity. All right. So that is issue of multicollinearity. Next, checking for model assumptions and outliers. Okay, no problem, eh? Okay. So the assumption, it must follow this line. Linearity, independence, normality, and equivariance. Okay. So first we have to show, okay. Why this one we don't check the number one random sample? Random sample, your study design. Okay. So by right, you can only use multiple linear regression if your samples are randomly selected. Tapi mana ada cari random? You all semua based on what? Convenience sampling. Siapa nak isi borang isi. Okay. So let's look at line. Okay, so now we have to start calculate the residual based on our preliminary data set. So what is the data that you want to put in? The significant ones, which is age, diet, and exercise. Okay, then you have to generate the linear value, the residuals. So you're going to generate both unstandardized and standardized. Okay, for predicted values and the residuals. Okay, I know this one they just do one by one, but I'm going to do everything one go. Okay, so click here. The same linear regression. Okay, 1, 2, 3 nampak? Ni yang biasanya. Okay, so we're going to click on save. We're going to generate this. Okay, dah sudah. Click OK. Continue. Click OK. They are going to generate 4 new variables. This predicted value, residual value, standardized value, okay, and also standardized residual. Okay, predicted value, residual, standardized value, standardized residual. Okay. So now we're going to proceed with the next step. Okay. So basically what happened, okay, I'm going to put it side by side. I'm going to put it side by side. This one, predicted value, is the predicted value of Y. So the predicted value of Y is the cholesterol level. So what happened now? Okay. Oops. This predicted value, the residuals, okay. What is the meaning of residuals? It is the difference between the predicted value and the cholesterol. So 6.6, this is the cholesterol level. minus 7.32. This is the predicted level using the formula that you generated. Okay, remember the formula? Okay. In case anybody forgot the formula. This is a formula that we generated. So based on the formula that you generated, you are going to get take the result from the age, diet, and exercise. Try to predict the value of the cholesterol. So the value of cholesterol predicted is 7.32. Then you compare the 7.32 predicted against the observed 6.6. So 7.32 minus 6.6, that's the residuals. So the residuals is minus 0.72. So that is the same thing we got here. 6.6, 7.32. This is the residual. So that is the meaning of residual. The difference between the observed value and the expected value. Standardized, you just use the standardization procedure so that same like so you can use the normal distribution table. All right. So that is the meaning of residuals. So you have to plot the residuals against the predicted value and show that they are equally distributed. There is no trend of the residual. So for that, you have to use a scatter diagram. I keep looking at my watch because I have to finish this on time. So scatter diagram. So simple scatter, define. Okay. Remember, we need to use the predicted value and the residual. So what is for the y? The y is predicted, the residual. What is the x? The x is the predicted value. Click OK, you get a scatter plot. It looks like this. Okay, so you just need a thick line in the middle. So to get a thick line in the middle, you just click this one, set to 0, click OK, apply, close. Okay, so now you got a nice thick line here in the middle. And you can see that these are all the residuals. And all the residuals are distributed randomly, and you draw a line. It looks like this. So you are okay. So you are okay. And that is explained in the next slide. Okay. So as long as there's homoscedasticity of the distribution, you are okay for multiple linear regression. Okay. That is the first part. So let's proceed with the rest. Okay, again, you already saw just now. Based on that, okay, I will show you the map. Okay, so this is what they mean by overall linearity. Overall linearity. Okay, so this is the linearity if it is continuous data for simple linear regression. This is the linearity for MLR. Okay, let's go back to the graph. Okay, this time I draw the graph using like that one. Okay, okay, I'm going to delete that one. Select, delete. Okay, now the line is gone. Okay, what you should have done just now, okay, was to get the fit line. So when you get the fit line, you double click on all these dots, right click, fit line. You will see the fit line is at 0. You will see the fit line is at 0. Cannot see, I know cannot see. Okay, let's change the color. line. Kasih merah sikit. Apply. Close. So you can see, see cannot see. Line. Make it bigger. Bigger. Okay, much bigger. Better. Okay. Doctor, it is not zero. Yeah. It is zero, okay? It is zero till the 15 decimal point. It is 0.000 sampai 15 decimal point. So it is really zero. Okay, not this value. Okay, so you are okay, eh? So that's get the feed line. Next. Okay, we already shown linearity. We already shown the this one. Okay, ours is like this, so we, the linear assumption is met. Okay, then we do the histogram of the residuals. To do the histogram of the residual, simple. Click graph, histogram, residuals. Click OK. Okay. So again, the mean is 0. The mean is 0. So we are okay. Next. We are supposed to check the linearity for each one, age, diet, and exercise. So what you do go back to scatter diagram, click graph, legacy dialog, scatter. Okay. Click simple scatter, define. Okay. Just now it was predicted value, so take out predicted value. So put each one of the variable. So first we start with diet. Click diet, click OK. Okay, so this is the first one. Again, no problem. Double click on the dots. Double click. Fit line, the total. Okay, again, no problem. Okay, legacy dialog, scatter, simple scatter. Take out diet, put in exercise, click OK. Okay, again, double click, click, fit line. See, at 0, cantik, no problem. And last one, tidur masa exam ni kan. Age in year, click OK. Okay. So again, no problem. Fit line semua cantik, all at 0. Fit line cantik, semua, everything, fit line is beautiful. Everything is at the 0 line. And the line shows that there is a linear relationship. Okay, and with that, I think we are towards the end already. Okay, this one is the standardized. Standard is very simple. You want to show that this standard residuals and the predicted value, no value is larger than 3. No value is larger than 3, so that you have no outlier. So to do that, again, click scatter diagram, graph, legacy dialog, scatter. Okay, we click on simple scatter, define. Okay, take out this one. Okay, put in standardized residuals, take out the age, okay. You can put in standardized prediction or, but never mind, we're just going to use unstandardized prediction. Okay, unstandardized with the value. Click OK. So you can see that there is no value larger than 3. Yes. Okay, there's no value, so we are okay. So there is no outlier in this graph. Okay, so that is how we do the exercise. And lastly, the interpretation and data presentation. So this is a very straightforward data set for MLR. Why very straightforward? Because we are saving the difficult one for logistic regression. So you can see here in this table, you can come up with a table combining both the simple linear regression and the multiple linear regression. Okay, for the prediction study, it is essential to report the final model, the equation. So this is the equation. All right. So these are all the values. Okay, you can get where you get these values from the table that we generated earlier. Okay, what has it we have shown? We have shown that the significant linear relationship between age and cholesterol level, the significant linear relationship between duration of exercise and cholesterol level, significant relationship between diet and cholesterol level. And when you have all these three variables together, they explain 69% of the variation of the blood cholesterol in the study, which is very good. Okay. And in short, this is how we do it. We do data exploration, scatter plot, preliminary mean effect model, preliminary final model, okay, final model, then your data presentation. So along the way, we have to export data properly. We have to select which one are really significant. We have to look at the interaction and multicollinearity. And you have to look at the assumptions and the outliers. Okay. So this one I'm not going to cover here now. We're going to cover later. Okay, the 1 and 0. So if you want to include categorical data inside multiple linear regression, then you have to code it using 1 and 0. Cannot use 1 and 2. Okay. All right. If it is more than 2 dummy variable, we have 1, 2, and 3. Okay. If you have a polytomous variable, then you have to come up with dummy variable. So like this. Okay, I'm not going to cover it now. I'm going to cover it later when we do logistic. If you have 4 variables, you end up having to create you have to create all these things. Lagi banyak. Okay. Okay. The more option that you have, the more dummy variable you have to create. Okay. So this is story about group recoding the different variables. I'm not going to cover this. Not necessary. So this one just explanation about the beta value inside the categorical variable. Okay. So how we explain similar like logistic regression. Okay. All right. And with that, we are done. Yay.
Prof, saya Sofia nak tanya boleh?
Boleh.
Macam dalam Prof Ayub punya lecture note, from SLR, he included all variables masuk dalam MLR. What if kalau macam from SLR, dah ada yang tak signifikan, would you masuk dalam MLR?
Okay, under Ayub, because it just happened, everything is significant. Okay. So for me, there are two schools of thoughts. One, you select the variables that you enter into the multiple linear regression. Okay. The other one is everything in. Let the computer decide which one is supposed to be part of the final solution. But the problem now, if your data has got any missing values, you cannot do that. Okay, for example, when we had this, I'm supposed to analyze the data for the pure cohort, the prospective urban rural epidemiology study. Yes, we got 13,000 data set, but the 13,000 data set, they are not all complete. Okay, so if I put in all the variables into the analysis, I get very weird results because there's so much problems with missing values. So with that kind of data set, I will be selective. I will select only those who are initially significant and those who are almost significant. So these are the variables that we want it to be to put inside the discussion, because in other studies it is already significant. So we take that variable and we see that the variable is almost significant, and then we put into the model, into the multiple linear regression. Okay. So your decision whether to take all or not, it's dependent on how complete is the data.
So far, alhamdulillah memang complete, tak ada missing data. It's just pening bila dah buat MLR. There was instances yang dalam, bila masukkan semua, ada yang tak signifikan dalam SLR. Bila masuk MLR, signifikan pula. Okay, itu satu pening. Ada lagi satu yang I baca, masukkan yang signifikan saja, yang P less than 0.05. Lepas tu baca lagi, ada rule of thumb yang masukkan P less than 0.25. Adakah I di dalam yang benar?
Kalau if your data is complete, then you can apply any of these three. Okay, but you have to understand. That there are always issues of the data nullifying each other. Okay, the data. Okay, for example, if you're doing a study on cervical cancer, okay, years of education, age of first getting married, age of first having a baby, they are all proxy of the same thing, which is age of first sexual contact. So if you put all these variables together inside the same analysis, they are going to nullify each other. So by right, age of first having contact, having sexual contact is supposed to be significant. Suddenly they end up becoming not significant. So when that scenario happens, then you have to be selective. You have to select the variables that are really you're trying to measure, and not the proxy, not the thing that mimics it. So anything that measures the same thing, okay, but is a different variable, should be dropped. So that is why the best way is only to select the significant ones plus those who are almost significant but not significant, especially if those are significant in other studies. So the 0.25 is a good way of deciding which one to select among the not significant ones. On my part, I will only do that if my data has no missing values. Kalau ada missing values, I will just take the significant ones. Alright?
Thank you, Prof.
Okay. So always remember, when you take too much variables, there are those that are measuring the same thing. Okay. All right. If there are no other questions, thank you very much for your attendance today. Anybody here who attended, do not scan the QR code.
Can I ask a question, please?
Siapa? Abdullah. Yes, question. Yes, Abdullah, go ahead. Your voice breaking up. Hello. I think we just lost Abdullah. Okay, I'm going to stop sharing now. Okay, Abdullah, Abdullah. Ahmad, are you still on?
Please, Prof. Ahmad.
Okay.
Prof, I will.
I think you have to type in your question.
Can you hear me, Prof?
Your line is breaking up, so that we cannot hear your question. You just type in chat. Okay. Hilang tu Ahmad. He got internet line problem. Okay, he's back. Okay, are you okay now, Ahmad?
Can you hear me, Prof?
And now I can hear you. Okay, what's your question?
My question, can I just capture a photo for my variables and put it on the WhatsApp group, then ask a question, please?
Can.
Okay, thank you.
Okay, all right. Okay, with that, I got to start for my exam on the other side for the undergrad. Okay, thank you very much for your attendance today. So I'm going to stop the recording. Okay.
Prof, while sementara tu, sorry, yang R squared yang 69% tu dapat from where? R squared 0.69?
Dekat table atas tu. I show you back.
Okay.
Okay. So if you look here, okay, I'm supposed to share screen. Share screen too. All right, share. Okay, right now you're seeing my SPSS. So when you run the analysis for the linear regression for the good model, okay. So this is the linear regression. So you can see here, this one has got the adjusted R square of 0.678.
Oh, okay, all right.
Okay, you got 0.69, you got 0.678. Take the 0.678 because when you do multiple linear regression, you take the adjusted R square. Okay?
All right.
All right. Okay.
Bro, sorry, bro. Thank you.
Thank you. No problem. Okay.
Prof, I sent the photo to the WhatsApp group.
Okay. I will answer once the exam for the students has got underway. Okay. I'm having exam for the undergrad. Okay. Okay. Thank you very much. Okay. I will end now.